Coming up right now is the Space Show.
This is your community radio station, 88.3 Southern FM.
Welcome to the Space Show, presented by members of the Space Association of Australia. Hello, I'm Andrew Rennie, and on the panel and mission control way back on Earth is Richard.
Thanks for the opportunity. My name is Dedi, and I'm a postdoc at CSIRO Mineral Resources, and we are also working with Swinburne University of Technology.
The poster we're standing in front of is called Iron Making on Mars. Mars is the red planet.
Yes.
And that red is because of iron oxide, is it?
Yes, that's true. It has a relatively high concentration of iron oxides compared to other planets. And that's what we are doing here, where we try to understand how to extract the iron into metallic iron from the regolith on Mars. Yep.
So how do you go about doing it?
Yeah, so basically, we want to apply the principles that we've already explored here on Earth and apply it on Mars. So here on Earth, we use carbon as a reductant to extract iron or to make steel. And on Mars, we have carbon in the form of carbon dioxide in the atmosphere. So theoretically, we can get carbon from the atmosphere, using splitting the carbon dioxide from the atmosphere to get oxygen and carbon. And then we mix the carbon with the regolith and then heat it at a certain temperature, for example, 1400 degrees Celsius, and then it will smelt the regolith, and then the iron oxides will be reduced and extracted to get the metallic iron. So that's the brief explanation or brief scenario of this process. Yeah.
And how would you power this iron production?
Yeah, so we've found some papers. They proposed using solar energy and probably using photovoltaic process, solar panel, or other things. So basically using solar energy as the heat source for this reactor. So that's what we are exploring at this point. And at Swinburne University, we have a simulator of solar reactor where we use lights to heat the reactor. And we've demonstrated that we could produce iron from this regolith using that reactor at Swinburne. Yep.
And how would you separate the iron from the other minerals there, like pyroxene, feldspar, olivine, and the sort of minerals that make up rocks?
Yeah. So if we talk about smelting process, for those who are not familiar with smelting, so it's basically the solid materials will go to liquidous states where everything will be in liquid. And with the presence of carbon, so the iron oxide will be reduced into metallic iron, but everything will be in liquid. So the metallic iron will be separated through the density, by the density difference from the other minerals. So basically we smelt them, we put them into liquid states, and then they will be separated automatically because of the difference in the density. Yeah.
Anything else you want to tell us about it?
From my perspective, this is a very exciting project. Even though my background has nothing to do with space exploration. My background is in metallurgy, but that's the beauty of science, where we can apply different angles to different specific topics. And in here, we apply our metallurgical principles to space. Yeah, thank you.
Well, thanks for joining us on the Space Show.
Thank you very much. Thanks for reaching out to me. Yeah. Thank you.
And now from Swinburne University, we'll pop over to Monash University. And this next one I recorded in late 2025.
My name's Joseph George. So I'm part of the Monash MHAB team. So this is Monash High Altitude Balloon. Our aim to launch a stratospheric balloon carrying a telescope to map out the sun, perhaps just cover like some solar flares, a bit more about like the sun and its phenomena. So we're a student team newly established. We kind of got the idea in September, had our preliminary design phase I think last Friday, and we're kind of basically building the team into a fully fledged Monash student team next month, I guess. So it's brand new. We've kind of had to come together, a team of 40 students, all really passionate about building this telescope and stratospheric balloon. At the moment, we've kind of got all our basic kind of equipment sorted out. We have an optics team, we have a mechanical team, electrical team. And we're all kind of designing this balloon and the telescope to look at the sun. Our aim, basically, to both kind of foster this love for space and space exploration at Monash, but also kind of develop a project that's sustainable for the future. High altitude ballooning is something in Australia that has a very vast scope, I'd say, and something that hasn't been researched much, and it's something for us to look to explore into in the future, I'd say, yeah.
How high do the balloons go?
Yeah, so we're looking at the moment around 30 kilometers to 38, so that's kind of our range at the moment. At this kind of altitude, we're kind of clear of 99.5% of the atmosphere, so we're not going to get much interference on the telescope that way. So we're basically looking to get a much more clearer cut image of the sun in comparison to ground telescopes and ground-based observatories. So that's kind of our aim with the stratospheric balloon and kind of its benefit. So yeah, we'd say at this juncture, 30 kilometers to 38.
And what sort of spectral range are you looking at?
Spectral range? So we're kind of investigating that at the moment. We're kind of just looking at basically mapping out the sun. They're telescopes specifically designed for the sun itself. So we're not looking to focus too much on other planetary bodies as of yet. It's basically the whole idea of carrying a stratospheric payload, and in this case it's a telescope focusing on the sun itself, yes.
Well, thanks for joining us on the Space Show, Joseph.
Good, thank you.
Now, most of you will be familiar with how dust sticks to things electrostatically. Well, there's such a thing as electrostatic levitation. It can happen in a vacuum, for example, on the moon. And it was first observed by the Apollo astronauts. Well, the Artemis II crew, as they went around the moon in April this year, were on the lookout for this. Let's take a listen.
Exosphere is the almost no existing atmosphere of the moon. It's barely there. But there is dust on the lunar surface that can get lofted up through electrostatic forces. And when the sun goes behind the moon, it can scatter forward on those dust particles and sort of like create a little glow on the horizon. And so we're really excited to see if the crew can actually see that.
Now, even though the crew will be flying behind the moon, their observation period does not stop. They will still be taking pictures and making annotations of what they are seeing. They'll be looking for the limb of the moon, Earth set, and then Vavilov crater, which we have previously seen. They'll swap positions at the window before moving into a crew choice option. They will get to pick things that are interesting to them on the surface, take pictures, and explain why they find them that way. They'll also be looking for any impact flashes. These are short-lived flashes on the lunar surface caused by impact bombardment. Just before Earthrise, the crew will be looking for lofted lunar dust. This may be lofted just above the lunar surface, and we could only see it just before Earthrise along the dark western limb. Any Earthshine would illuminate potential lofted dust. But once the crew is all the way around the Earth, the brightness of the Earth will wash out any of that dust they might be able to see. These were based on observations from Apollo missions and orbital spacecraft, and so we're very interested to see if the crew might be able to capture some of that lunar dust today.
And the crew did see some impact flashes of objects hitting the moon, and mission specialist Christina Koch reported that she had seen levitated lunar dust. Now, that was related to that finding by Christina Koch of the lunar dust levitation as seen from Artemis II. Well, back in Artemis I, several years ago, they launched a number of CubeSats from the rocket, and one of them was called BioSentinel. Sergio Santa Maria, it was the principal investigator of space biosciences at the Ames Research Centre, and shortly after the mission was pretty much a couple of months into it, he had this early results from the mission.
BioSentinel, I'm currently still the PI of BioSentinel, I believe. Launch, as all of you know, SLS Artemis I on November 16 last year. So it's been pretty much 6 months since we launched. So we had two actual launches, two missions associated with BioSentinel, one on ISS that we launched on December 2021, and stay on ISS until August. This was a control testing of all the hardware, the electronics, the data, the scripts, etc. So this ended in June last year, but we had the payload back in August. We had some minor issues with this payload, particularly on our last experiment, 1 of 9, as you will see in the next slides. And of course, Artemis on November last year, currently at approximately 17 million kilometers away from the center of the Earth, still nominal, still functioning. BioSentinel, all this has been published, so feel free to look at our open access publications. Inside there are a lot of components, primarily everything that needs to survive in deep space, to survive to the cold environment, to be able to contact the DSN, send the data back, and of course the main focus being the biosensor unit that contains a series of microfluidic components to support life experiments. And of course, another objective is to study the radiation environment, for which we have a spectrometer that measures both the amount of radiation, the total dose, as well as the type, so the spectrum of radiation particles in space. This is the different components. This has been published before, and we had the unit on the ISS at the bottom left. There are 18 fluidic cards that have biology inside, in this case, the budding or brewers yeast Saccharomyces cerevisiae, that they were pretty fine on the ISS. However, on the free flyer, we noticed early on around Christmas, or a little bit over a month after launch, that we're starting to get some electronic measurements that were kind of off. Then we ended up discovering that it has to do primarily to an increase in, potentially, an increase of the humidity inside. What ended up happening is we continue pushing to try to fill fluidic cards. We successfully fill a few of them, I believe 4 to 6. We did not observe cell growth, unfortunately. And we were kind of, it was a big bummer, but we kind of had an expectation this could happen just based on what we observed on the ISS in terms of humidity increase and the duration of the time the biology was sitting inside this box, inside the rocket, at ambient exposure, so humidity, temperature, etc. This slide shows you the LET spectrometer data. What have we obtained so far? So we did some modeling publication recently that estimated to be 0.25 milligrade per day of radiation total. We have observed more. As of right now, we are probably reaching the 60 milligrades or 6 centigrades. That is more than we planned, and this is because having multiple solar events, and we have captured all of that. We'll be publishing this in the upcoming months, and we'll make all this data available to the community in terms of all the radiation, not just total absorbed dose, but also the spectrometer, the spectra data from the machine. And of course, this just to show the characterization of the first 49 days, the spectra going all, from low energy particles all the way to high energy particles. And so nothing special, but pretty exciting being able to capture this data on such a small spacecraft. And even though it's not official, we are potentially getting an extension for at least another 6 months to record more data, reaching towards a solar maximum, as you all know. Just an example of what we observed in terms of solar particle events. On the bottom right, it's our spectrometer, just measuring, in this case, absorbed dose rate. And you can see the increases when we got, in this case, 2 coronal mass ejection solar events in February. One more, please. Very similarly, we observe another longer duration solar event in mid-March, and we're able to record that data. We still need to analyze all this. What doesn't matter of what we have learned from BioSentinel, the successful in terms of technology demonstrations, validation of the technologies, the electronics, the optics, and all that stuff, communications, data management, processing, it has helped towards this mission, which is LEA. The Lunar Explorer Instrument for Space Biology Applications. We were awarded, my co-PI, Mark Settles, and myself at NASA Ames, were awarded this mission to lunar surface on Eclipse lander in 2026, and it's based on BioSentinel, and it's going to have an additional LET spectrometer as well as a mini fast neutron detector to characterize that radiation environment on the surface of the moon. And of course, biology, try to characterize the response and the production of bionutrients or synthetic biology characterization. And we're trying to improve everything we learn from BioSentinel for this mission in terms of improve desiccation tolerance of the biology, improve desiccation tolerance or humidity tolerance of the electronics, and so on. So we have generated, again, an instrument that we went to ISS, so lower orbit, trying to go to lunar surface, and of course into deep space. And we're hoping that it gets in other places.
Sergio Santa Maria from the Ames Research Center in California. Now, if you'd like to know more about the experiments that are going to be going to the moon or might go to the moon, you might listen to our Lunar Science series. Lunar Science.
Surface is fine and powdery. I can pick it up loosely with my toe. It does adhere in fine layers like powdered charcoal to the sole and sides of my boots, but I can see footprint of my boots and the tread and the fine sandy particles.
Welcome to Lunar Science, the series in which we discuss the scientific investigation of the moon and its environment in the Artemis era. Yes, the Space Show is pleased to announce a new 54-part series called Lunar Science. This is not about spaceships and astronauts. It is about the science to be done on and near the moon during the Artemis project and the supporting unmanned missions. To find these programs, visit space.southernfm.com.au. Then scroll down until you see the Lunar Science link. Once again, Lunar Science is available online at space.southernfm.com.au.
You're listening to 88.3 Southern FM, the sounds of the Bayside.
Where on the Space Show we're going to turn back time. Several weeks ago we turned back time 60 years to the Gemini 9 mission, and we told about how that mission was prepared and then ran into trouble. Well, the planned Gemini 9 mission to dock with a target vehicle had to be postponed. Here's how it was reported by the Voice of America.
America's Gemini 9 mission has been postponed until Friday because of computer trouble. We'll have the details of the story at Cape Kennedy later in this newscast. The flight of Gemini 9 was postponed again today when a last-minute malfunction halted an almost perfect countdown. The new launch date is Friday. Less than 2 minutes before today's scheduled blast-off, something happened that blocked final data from reaching the spacecraft's computer. The disappointed astronauts, Thomas Stafford and Eugene Cernan, again climbed down from their spacecraft atop the huge launch rocket. The 3-day Gemini mission was postponed 2 weeks ago when its target rendezvous vehicle failed to reach orbit. Today, a substitute rendezvous target was launched successfully and is now in an almost perfect circular orbit 296 kilometers above the Earth. But even its success has been marred by a possible malfunction. A protective covering on the docking collar of the target vehicle may not have separated from the craft as it should have. This would mean that the Gemini astronauts can rendezvous with the target but cannot dock. The astronauts expect to find out on Friday.
Well, 2 days later, another launch attempt was made.
Thomas Stafford and Eugene Cernan today will make their third attempt to fly into orbit in the Gemini 9 capsule. Their first try was canceled when a target satellite failed to orbit. A target vehicle did go into orbit Wednesday, but computer trouble stopped the Gemini launching at the last moment. Today's launching from Cape Kennedy is scheduled for 13 hours 39 GMT. The Voice of America will begin radio coverage of the event at 13 hours GMT. Astronauts Stafford and Cernan will try to rendezvous with the target satellite in their first 3 orbits and dock or link up with it. There's one problem involved in this experiment, and here's Voice of America correspondent Ed Hickey with a report on it. Mystery still surrounds the protective shroud that covers the docking collar of the target vehicle launched Wednesday, with which Gemini 9 will rendezvous once in space. The 400-pound shroud was supposed to blow off in orbit, but officials have never received a verifying signal. In the event the shroud hasn't separated, Gemini 9 will be unable to carry out the docking maneuvers. Asked how important this aspect was to the Gemini project, space officials pointed out that docking was performed on the Gemini 8 mission last March and was also scheduled for Gemini 10, 11, and 12. Deputy Flight Director Christopher Kraft explains.
Although we would like to get some docking practice under various lighting conditions and, in fact, under various rates of this ATDA, because that's of interest, I really don't think that's a very major objective of the flight. If it's the methods of rendezvous that we're really after here more than the docking.
Deputy Flight Director Christopher Kraft. Ed Hickey, Voice of America, at the Manned Spacecraft Center, Houston, Texas.
And then came the live broadcast of the Gemini 9 launch.
This is the Voice of America broadcasting from Washington with live coverage of the flight of Gemini 9.
This is Brett Turner at Cape Kennedy, Florida. The weather is almost perfect for the launch of Gemini 9. The target vehicle is at this moment completing 2 days in space and is coming across the Pacific Ocean toward the United States. When it comes across Cape Kennedy just 39 minutes from now, if all goes well, Gemini 9 will blast off pad 19 here and go after it. There's a slight wind coming in from the Atlantic to the east, and downrange the emergency pickup forces are standing by in case of trouble. Around the world, the tracking network is completing last-minute equipment checks as they wait for the 2 astronauts to go into space. The small piece of equipment here on the ground, which prevented launch on Wednesday, has now been changed. And everything on the ground is ready to go. Let's go to launch control for the latest from
Gemini launch control. T-minus 34 minutes and counting. T-minus 34 are still going excellently at Launch Complex 19 in our Gemini 9 countdown as the ATDA target continues to swing around on its 29th revolution. At this point in that countdown, we're going through a series of flight control checks with the Gemini launch vehicle and overall telemetry checks between the launch vehicle and the Air Force Eastern Test Range tracking elements.
Then came the exciting moment. The Titan II rocket ignited to boost Gemini 9 into orbit.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. We have ignition. We have a liftoff. It looked like 39 minutes, 32 seconds after the hour.
And coming across the Cape, we can see the big Titan booster moving. It's now about 100 meters in the air, moving up fast. And now you will hear the sound of this booster, the pale pink rocket plane from these hypergolic fluids. Now about 3,000 meters in the air, beginning its pitch program, pitch and roll beginning. And it's moving fast up into the sky and pitching over to the east.
The Voice of America went live during the rendezvous as the 2 spacecraft passed over Australia.
The time of rendezvous between Gemini 9 and the ATDA target adapter is very near now. So for direct reports on this, we go to the Manned Spacecraft Center in Houston, Texas, and correspondents Robert Lodge and Edward Hickey. Well, here at the Manned Space Center, we're still awaiting a late report from Gemini Mission Control, the voice of Al Chu. Any moment now, they should be making the final adjustment in order to bring them in very close to the target adapter. And we are still awaiting word on whether that shroud is still covering the adapter. To repeat for some of our listeners, since liftoff, radar tracking of the target vehicle from the ground has not revealed whether the shroud covering the target adapter at liftoff had been jettisoned away as it should have been soon after liftoff. Now, hopefully, the astronauts, through visual setting, will be able to tell us whether that shroud is still covering the target adapter. This uncertainty has presented some problems in planning the detailed activity of the three-day flight. If the shroud is still covering the target adapter at the end of the target vehicle, there will be no docking, and all rendezvous and re-rendezvous maneuvers will occur before Gene Cernan climbs out for his 2.5 hours of extravehicular activity. We're expecting a report now on the from Gemini Mission Control. And Hickey? Yes, Bob. I had a brief time, but I think I'll hold that now. We have it on there from Gemini Control, so let's listen. Gemini Control, Al Chu.
This is Gemini Control, 3 hours and about 60 minutes into this mission. We have Gemini 9 passing now into the range of the Canalvin tracking station, and the PDA or target is 3.5 miles in range, and we will switch now to pick up the voice communication between Canalvin and Gemini 9.
Voice transmission from the spacecraft.
We're at 88.2 degrees and 3 miles.
Copy, Mike. Up, hold up here. Range 5 Roger.
PDA, we just started the heavy close-up portion of 3 forward and 2 down.
Copy, Mike. Hold up here.
Okay, PDA beacon up.
That's affirmative. Gemini 9, talking to the tracking station.
That's pretty good. Gemini right now. Okay.
Earlier, the astronauts have reported some...
Spacecraft C-band track.
That's affirmative.
Okay.
They had reported some difficulty with their computers on board the spacecraft.
The Gemini 9 will have the left turning range of that last 2.5 miles.
They see the light of the target adapter apparently. That was that. That's a good indication of the power of away.
The Gemini 9 will put some point of flight will be breaking directly into the moon. It should be an active problem.
Roger. Voice of
Gemini 9 was at 910.9, range 2.37 miles, 300 feet per second.
Now about 4 kilometers away from the target vehicle. We heard the voice of Command Pilot Tom Stopper.
Having crossed Australia, Gemini 9 and the augmented target docking adapter flew out over the Pacific Ocean past Hawaii, and the two were only meters apart. The view was described by the crew. The target's shroud had opened a little, giving the appearance of the jaws of an angry alligator, or as we would say here in Australia, an angry crocodile. After some discussion, it was decided that it would be too dangerous for the astronauts to free the shroud, and so a docking would not be possible.
Space officials and Command Pilot Thomas Stafford trying to discover a way to remove the target shroud so the two vehicles could connect in space. While awaiting their decision, the VOA coverage team outlined some details of the climb experiment, techniques of rendezvous, which the astronauts were performing even as the VOA team was discussing their mission.
The Voice of America summarized the flight so far.
Objectives of this flight are to complete the 3 different types of rendezvous maneuvers scheduled for this flight. They would like to bat, of course, the practice with crew themselves. But the main objectives are the rendezvous maneuvers, and they'll do this 3 times throughout the flight. They'll do it today and again tomorrow. So they'll separate themselves from the target vehicle, get themselves some distance away, and come in again. In one particular case, it will simulate a return flight from the moon, in which there might be some difficulty in that they'll have to come in from above the target vehicle. Much as the Lunar excursion module returning from the moon would seek out and rendezvous with the mothership that had been in orbit around the moon while 2 astronauts touched down and explored the lunar surface. This, of course, in flights another 2 to 3 years away. But a very important technique they hope to carry out on this Gemini 9 and the remaining Gemini flights.
VOA's Tom Hickey describing the various rendezvous maneuvers being performed by Gemini 9 and its target ATBA in space. Late Friday, a decision came not to try to connect or dock the 2 vehicles. To tell about that and look ahead at cosmos activities, VOA's Ed Hickey files this report from Houston.
For the first time in history, American astronauts have successfully completed delicate rendezvous maneuvers in space. Flying at a speed of more than 28,000 kilometers per hour at an altitude of 160 miles or 270 kilometers above the Earth, Gemini 9 astronauts Thomas Stafford and Eugene Pettit dramatically closed the gap between their spacecraft and the target vehicle, easing to within 3 to 10 meters of it. The space meeting took place on the dark side of the world over the Pacific Ocean near Hawaii and culminated a series of precise maneuvers that began moments after Gemini 9 blasted into orbit exactly on schedule at 13 hours 29 minutes Greenwich Mean Time Friday. As the Gemini 9 spacecraft circled around the target vehicle, astronauts Stafford and Stern cleared up the mystery concerning the protective shroud that was supposed to separate from the docking collar after it was in orbit. They reported that the shroud was still attached, but partially open and hanging by 4 wires. We have a weird-looking machine, astronaut Stafford radioed, describing the 2 halves of the shroud as looking like the open jaws of an alligator. His vivid description from space sent ground controllers to work, trying to find a way of shaking the shroud loose so Gemini 9 could dock with the vehicle. Stafford suggested that nudging the open jaws of the shroud would require a spacecraft, but the controllers ruled this out before he received signals from the ground. By extending and withdrawing the docking collar, they succeeded in moving the shroud slightly, but it did not jar free. While controllers continued to work on the problem, Gemini 9 pulled away from the target vehicle, circled the Earth, and then completed a perfect re-rendezvous maneuver. After the second rendezvous, Gemini 9 again moved away, and the astronauts went to sleep, thus ending a busy but successful day in space. On Saturday, Gemini 9 will rendezvous with the target vehicle for a 3rd time, and astronauts failed to attempt a spectacular 2.5-hour walk in space. Ed Hickey, Voice of America, at the Manned Spacecraft Center, Houston, Texas.
With the multiple docking techniques demonstrated, Gemini 9 flew away from the target vehicle to move on to the spacewalking activities. Now, aware that many people cannot fully understand English, the Voice of America broadcasts simplified news reports read slowly, as in this example.
Space News. United States space officials are trying to decide if it will be possible for the spaceship, the Gemini 9, to join an object in space called a target satellite. The Gemini 9 was sent into space from Cape Kennedy, Florida, today, 2 days after the target satellite was sent to circle the Earth. The Gemini 9 spaceship carries 2 astronauts, Thomas Stafford and Eugene Cernan. They have completed the first attempts to join the spaceship with the target satellite. The joining is called docking. The astronauts have not been able yet to join the spaceship with the target satellite as planned. This is because a cover still is hanging from the satellite. This cover should have dropped from the satellite when it was sent into space Wednesday, but it failed to do so. United States space officials on the ground and the 2 astronauts in Gemini 9 are trying to find a way to settle the problem. The plan is for the Gemini 9 to make a number of attempts to come together with the target satellite. Another important part of the Gemini flight will be a walk in space by astronaut Cernan. He plans to leave the spaceship and float in space for about 2 hours tomorrow. The Voice of America will report on the walk in space as it happens. This is expected to be between 11 hours and 15 hours Greenwich Mean Time, Saturday. The Voice of America also will report on Gemini 9's return to Earth, now planned for Monday. In other space news, America's Surveyor space machine has sent back its second group of pictures from the moon. Scientists called them surprisingly clear and said they showed many details of the moon's surface. The American space machine made a soft landing on the moon early yesterday and sent back its first group of pictures soon after. The second group shows the surface of the moon, the edges of the moon, also the space machine itself. Scientists said the successful flight and landing means the Surveyor program will be completed 1 year earlier than planned. The Surveyor is an important part of the plan to send American astronauts to the moon by 1970. This is Mel Quid reporting from the Voice of America in Washington.
At the end of the Gemini 9 mission, the Voice of America provided this summary.
The Gemini 9 flight, which was launched from Cape Kennedy last week and ended in the Atlantic Ocean Monday, illustrates how close the margin is between achievement and failure. Out of many thousands of factors that must be considered, any one factor may be enough to frustrate full achievement of the objective. The Gemini 9 mission accomplished part of its objective. Astronauts Stafford and Cernan brought their craft into a rendezvous with another vehicle launched earlier. But they were unable to dock, that is, link the 2 craft together, because a protective shield had not disengaged from the target vehicle as it was supposed to have done. Astronaut Cernan, nevertheless, left the Gemini cabin and moved around outside of it for some time, performing various prearranged tasks. The so this part of the exercise was shorter than planned. Both docking and spacewalking are techniques that must be perfected for interplanetary travel, including travel to the moon.
88.3 Southern FM. The sounds of the Bayside.
We're now going back to turning back time to 1960s. Now, during the 1960s, a series of satellites called the Orbiting Geophysical Observatories were launched. As their name suggests, their aim was to measure the magnetic and radiation environment around the Earth. The first was launched in 1964 and the sixth and last in 1969. 60 years ago, on 1966 June the 7th, the third was launched. This report from the Voice of America.
A huge unmanned spacecraft, which will perform a number of scientific experiments, was rocketed into space at Cape Kennedy late Monday night. It is scheduled to go into an elongated cigar-shaped orbit, which will take it out into space a distance of 76,000 miles. That's about 120,000 kilometers. The spacecraft is called OGO-3, short for Orbiting Geophysical Observatory. It will carry out 21 experiments dealing with relationships between the Sun, the Earth, and the planets. It will report back on such phenomena as the solar wind, solar flares, terrestrial magnetic field disturbances, and the like. This news is coming to you from Washington.
Now, one of the problems in spaceflight is orbital debris. Fragments of rockets and satellites orbiting our planet at 28,000 kilometers per hour. One major contributor to this debris problem is rocket explosions, usually from leftover fuel. The first major explosion happened 65 years ago when a United States upper stage rocket called Star broke into 321 tracked objects. The Star had been used to launch the Transit 4A navigation satellite and the Greb-3 military intelligence satellite. In other look-back news, 60 years ago, negotiations began on what was popularly called the Moon Treaty. This report from the Voice of America.
The United States welcomed a Soviet proposal for an international treaty banning territorial claims to the moon and other celestial bodies and forbidding their use for military purposes. America's ambassador to the United Nations, Arthur Goldberg, said the United States welcomes what appears to be an affirmative Soviet interest in a similar proposal made by President Johnson on May 7th. Both proposals also call for international cooperation in space exploration.
Today's news analysis is by Harold Corlander. His topic, the prospect of an international law to control human behavior on the moon. The importance of an agreement that will limit use of the moon to peaceful purposes has been made evident by two so-called soft landings of instruments on the lunar surface within the past few months. One by the Soviet Union's Lunar 9 in February, the other by the United States Surveyor 1 this week. It is no longer in doubt that men can place instruments safely on the moon and make them operate there. And it has been demonstrated frequently that men can function in space, even when outside the vehicle they depend on for transportation. These accomplishments, which seemed tentative and distant only a decade ago, have vastly widened man's frontiers and his potential for peaceful technological development. But they've been accomplished in an age of international tensions, when little progress has been made toward disarmament and the control of atomic weaponry. Just what use the lunar surface could be to an advanced nuclear nation has not been elaborated upon, but the possibilities are ominous to contemplate.
The nations with the greatest capability in both space rocketry and nuclear armaments are, of course, the United States and the Soviet Union. It was a measure of their concern over the military purposes for which outer space could be used that they joined in 1963 to draft the United Nations resolution on legal principles to govern space exploration. A month before, the General Assembly had adopted by acclamation a resolution that called on all nations to refrain from using outer space for stationing or orbiting weapons of mass destruction. But both of these commitments are only statements of principle. With instrument landings on the moon already accomplished, and with manned landings soon to come, there is an increased awareness that some form of binding convention is required if the moon is not to become a base for weapons of mass destruction. Early last month, President Johnson announced that the United States was taking the initiative for a treaty under UN auspices that, among other things, would guarantee free access to and exploration of the moon and other celestial bodies by all nations. The proposed treaty would prohibit any nation from making claims of sovereignty on celestial bodies and would forbid the use of celestial bodies for the stationing or testing of weapons. That the Soviet Union is in general accord with these American proposals was made evident on Tuesday of this week. The USSR proposed that a treaty on the moon and other celestial bodies should be placed on the General Assembly agenda this year. What the Soviet Union would like to see in such an agreement is substantially what is contained in the U.S. proposals already submitted to the UN Committee for the Peaceful Uses of Outer Space. Compared paragraph by paragraph, the Soviet and American proposals have a remarkable similarity and might well have been prepared from a common original draft. If the similarity of the two proposals in major respects is any clue, there will be in the foreseeable future a binding agreement to cover the behavior of human beings on lunar terrain. Such an agreement will be vital to the welfare of all nations, even those whose domestic problems will keep them earthbound for some time to come.
That news analysis was by Harold Corlander.
And the Outer Space Treaty was signed in 1967. Not all nations signed, but one of them was China, which is now prompting the race to the moon. Why is there a race to the moon? Well, because water has been discovered at the south pole of the moon. Not liquid water, solid water. And this has been the Space Show with Andrew and Richard.